Did you anything for that? Oh, I did.
We're going to let theta be an acute angle in the standard position whose terminal side contains the ordered pair 3, 5. And then we're going to find the 6 trig functions of theta. So like a picture would be, and I would think you would want to draw a picture. Now here's what some people will do. They'll go right to this formula and they'll say x is 3, y is 5. They'll use Pythagorean theorem to find r, and that's totally fine. And then they'll just do that. I'm going to just draw a picture so you see what we're talking about. Uh-oh. 1, 2, 3, 4, 5. I'm going to go off the page. So 1, 2, 3, 4. That's what I'm going to do. I'm just talking to myself. 1, 2, 3. 1, 2, 3. Okay. So if you want to think of this as a triangle over 3 up 5, if I wanted to find the 6 basic trig functions, I'm going to need to find the hypotenuse. So I do that. 3 squared plus 5 squared. Let's see, that's 9 plus 25, right? Which is 34. I'm going to leave it as the square root of 34. Okay, this is called a reference triangle. So we can think SOHCAHTOA, or you can use the handout that I just gave you with the x-coordinate, the y-coordinate. R represents the hypotenuse. And we just go through. What would sine of theta be? 5 over root 34. And if they are not exact ones would be 30 or pi 6, 60 or pi thirds, and 45. So as long as they're not exact, we're not going to bother rationalizing. Cosine is adjacent over hypotenuse. So 5 over root 34. Tangent is up. What? Wait, what?
You said 5. But...
Oh, I said 5? I'm sorry. 3, sure. What's tangent? Yep, 5 over 3. And then I like to just then go from there and do my reciprocals. The reciprocal of sine is cosecant. Would be root 34 over 5. Is this sounding familiar? Just quiet.
I think so.
Secant is root 34 over 3, and cotangent is 3 over 5. Okay. So, same scenario. What I want to show you is what if you had the terminal side that wasn't an acute angle, that it ended up being an angle that was in a different quadrant. Let's just review quadrants a moment. This is called quadrant 1. We usually use Roman numerals. The x-coordinate and the y-coordinate are both positive, right? This one is called quadrant 2. We talked about this already. Which coordinate is negative in quadrant 2? Just the x. So anything involving the x in a minute is going to be negative. This is quadrant 3. Aren't they both negative in quadrant 3? And then this is quadrant 4. And this one, the x-coordinate is positive and the y-coordinate is negative. Okay. So I'm not going to go through because I think it's redundant to write this whole thing out again. Would you agree with that? Okay. So this time, we're going to do same as above. But this time the terminal side contains, let's do -3, 5. Now, as I was saying, if you would like to use the blue paper and just recognize, hey, this time x is a negative value, so any function involving x would be negative, that's fine. By the way, when you take the square of something, what happens to it? It makes it positive. So r is always going to be positive. Or, if you prefer, you can draw a reference triangle again. So I'll show you what that would look like. So this time, -3, 5 is right here. Okay, now this is where people get confused. Are you ready? You all agree that that would be -3, 5? This angle did start here and it rotated around to here. So theta really is an angle that's between 90 and 180. But when I'm making a reference triangle, do you remember what we said about reference triangle? It always has to be made with the, you don't remember. A reference triangle always has to be made with the x-axis. So if I wanted to do SOHCAHTOA, I would be using this triangle right here. Okay. I know in a triangle, normally sides aren't negative, but it's a reference triangle. So because it's over here, this would actually be a -3. This would be a +5, okay? And what about the hypotenuse? We already did that work, didn't we? That's why I picked this one. So it would still be √34. Are you following? Okay, so even though the angle's here, my reference angle to help me figure these out is the angle made with the x-axis. The sign would be opposite over hypotenuse. That's 5 over √34. So did the sign change at all from the problem above? No, because that doesn't involve an x-coordinate. What would the cosine be? This one changes because it's a -3 over √34. The tangent would be 5 over -√3. By the way, you could write that as just -5/3 if you might see it out in front. All right, I'm doing this. Can you flip those around? Okay, let's not bother writing them down. All right, quick question for you. Look at this. Which functions, which of these 6 would be negative in quadrant 3 if the terminal side was in quadrant 3? Tell me which trig functions would be negative. Why not tangent? Because you'd have a negative over negative, which would also, right? Is that making sense that you could think about which ones are positive? Perfect. Okay, then the last thing we should do before we practice is we should do a perfect one. Not a perfect one, a special one. Yay. Okay. Now, here's what I'll tell you about this. Some pre-calculus teachers, when they do exact triangles, the perfect ones, the 35, the 40, the 30, the 45, and the 60, they have them use reference triangles 100% of the time. I had a student who transferred here from another school, and once we did the unit circle, she said, I just learned it using a reference triangle. Can I do that? And I said, fine. The beauty of the unit circle is that you get all of the exact measures in one shot. There's 16 triangles on the unit circle, and they're all of the exact measures you would ever need. So that's why I have people memorize that. But we'll learn that tomorrow. All right. Wait, what? I teach you a hand trick. You can do it on your hands. No, somebody said he didn't. No. What? This quadrant 1, right there. Quadrant 1.
I think you came into the classroom while he was teaching, and you taught us, and then he was like, "Yeah, I didn't tell you, but there is an answer." I did not recall.
Interesting.
I'm not going to use that. You came in and showed up.
Yeah.
No, I'm losing my mind. I don't remember.
Do I have to use your hand trick?
Oh, those are the people who took it 2 years ago. That's maybe why. Find the 6 basic trig functions of, let's do 315. Okay, now, what we have to remember, and I'll write these on the board once we learn them tomorrow, then you won't need this anymore. A 45-90 triangle, which, by the way, 45 degrees is the same thing as pi fourths. So we might do some with pi fourths. These are the same, and this is root 2. You remember that from the other day? Okay. In a 30-60-90 triangle, we call the shortest piece 1, the hypotenuse is 2, and the longer piece root 3. Okay, in a minute, we're going to make that reference triangle for 315. Well, not the second one, the first one. All right, so where is 315 degrees? Quadrant 4, specifically. Now, this doesn't have a terminal point because if I know the perfect triangle, I'm just going to do a reference triangle for it, okay? Specifically what? 315, let's see, we got 90, we got 180, 270. We keep going. Where's 315? $45 degrees between here and here. Okay. 45 degrees is the key word there. So we're going to draw a 45-degree angle. Okay. I'm going to write the 315 there. My reference triangle that I'm going to draw is the one that's made closest to the x-axis. So I'll draw a reference triangle. You can drop it down anywhere you want, but would you all agree that that angle right there is 45 degrees? Let's draw our triangle. The shorter pieces are each what? In the 45-45. So this is 1, but this is down 1, so I'm going to write -1, and this is root 2. When we're doing this in other quadrants, we're going to use those pieces, make sure they're in the right spot, and then we do our 6 basic trig functions. All right. Sine would be opposite over hypotenuse, -1 over root 2, and we rationalize. That's -√2 over 2. Cosine of 315, what's that? Cosine?
Which is
1 over root 2. So can we just skip that and go right to rationalizing? That's going to be positive root 2 over 2. How about tangent of 315? Good. All right. Just so we're clear on this, because I had some people doing this wrong the other day, when we're doing reciprocal functions, we're not taking the reciprocal of the angle. Like if it's pi over 3, we're not making it 3 over pi. If like this was pi over 4, I wouldn't make it 4 over pi. You're taking the reciprocal of the sign. So if I flipped this around, that would be -√2, wouldn't it? Because it would be root 2 over -1. And then the secant would be positive root 2, and the cotangent would still be -1. So that's how we use a reference triangle with our exact measures.